Greetings. Let's take a look at this derivative problem we didn't get a chance to finish up yesterday. So we're looking for the derivative of 1 over x minus 2. So we're doing the derivative of a rational function. All right, now we're doing the derivative the long way. Remember, whenever you have an x, we're inserting x plus delta x. So basically the change in x into the function, and we're subtracting the original function, the original f of x. So this part we had set up, everything was going fine. But let's not forget, remember it's the function evaluated at x plus delta x minus the original function, all divided by delta x. So let's not forget about this part. We're going to ignore it for a minute, but this is the part in our rush yesterday. This is the part that's going to help us out in the end. All right, so everything was going right. We were finding a common denominator. I'm looking at the two fractions in the numerator here. And we said that, notice what I've done here is these parentheses on addition and subtractions don't really force anything to be different as if the parentheses aren't there. So I'm taking these parentheses away because there's no multiplication, no distributive property. So we're calling this x plus delta x minus 2, the other denominator x minus 2. So as you were doing appropriately, you were getting a common denominator, multiplying the numerators by the part that's missing. So we have x minus 2 minus this other expression. Okay, don't forget to wrap these in parentheses because you're going to distribute that negative. Okay, so we cleaned it up. So here we get an x minus 2 minus x minus delta x and then minus negative 2, which is plus 2. Okay, we're starting to clean up our numerator. Notice it's x minus x. Those go away. We have a negative 2 and a positive 2, and we're left with negative delta x. Okay, so in our rush yesterday, here's what threw us off, is we're saying, well, what's the limit now as delta x goes to 0? And we were finding this to be 0, and that didn't make sense for this problem. So we don't want to find the limit as delta x approaches 0 just yet. Remember, don't forget about this. We're basically taking this fraction and dividing it by delta x, right? So you're dividing by delta x, which if we do a keep change flip, is the same as multiplying by 1 over delta x. Okay, so now we have a delta x in the numerator, delta x in the denominator. That will help us come down to negative 1 over our common denominator. Okay, now, don't need to multiply these two expressions together, because what's going to happen is now we can do the limit. We're going to say the limit as delta x approaches 0, which just removes this delta x. So we get negative 1 over x minus 2 times x minus 2. Another way of saying that is 1 over x minus 2 squared. So this is the derivative of the original rational function, which was 1 over x minus 2. Okay, now define the tangent at any particular point. I'm trying to remember what the point was. Can't remember exactly, but say, I'm thinking the point might have been something like 4 and 1/2. So now you can plug your 4 in. We get 4 minus 2, which is 2 squared. So the slope at 4 would be negative 1/4. Okay, so what threw us off is we were getting a 0 when we were setting the limit to 0, but what we forgot to do was divide by our delta x, which gets rid of this delta x, and we're left with this function. Now again, there is, as in the next couple weeks, you're going to learn shortcuts to finding derivatives, and I'll show you once you learn that how we could quickly have found this derivative without going through this process. But anyway, you have to go through this painful process of doing derivatives the long way, and then there's going to be some shortcuts, things called the power rule and the product rule and the quotient rule, and things that will make this much easier. I hope this helps. Talk to you later.